It's getting recorded. Yeah. So we have replication schedules, peers, and snapshot policies as part of this backup. So you look at these things closely. What been mentioned by me just before, dist CP, where we specify the source URL, destination URL to copy the file or directories recursively. That is what dist CP is. Distributed copying, distributed copying. From one cluster to the other cluster. I think you understand when this kind of situation arises. Copying the data from one cluster to the other cluster, even in terms of your regular activity, maybe from your production environment to your testing or development to your testing and production environment. If you need to move the data, you need to have a provision, and that is being given in the form of dist CP, distributed copy. Copying the data from one, and here the URL is important. What do you mean by that URL? What do you mean by that URL?
Okay.
That is the folder, okay, right? The source folders.
Yeah.
With the cluster name. It will come with the cluster name and everything.
True. So URL is nothing but, here if you look at that one closely, your URL is nothing but you have, anywhere URL has got the same meaning. No much difference between the other URLs and this URL, but here the values are different. So what URL will constitute? Protocol, then we'll be having IP address, then we'll be having port number, then we'll be having resource name. This is a usual structure of any URL. So what is a protocol here? What is a protocol here?
No, that's like HTTP or HTTPS.
Yeah, what is a protocol in our case? So the protocol is going to be usually HTTP or HTTPS or FTP, any of these. What is a protocol here now? So that is the reason why I am asking you to specifically understand this one. To specifically understand this. So here if you see, you have the protocol called HDFS, which you'll be seeing /opt /cloudera /parcels /lib cdh, and then we have so I asked you to go through this one a couple of times. I don't know whether you have gone through any time or not. You have something called conf. And here you see hdfs-site.xml. There, if you go and see, replication factor, all those things you will be noticing here. Along with that, we will also be seeing one second. You noticed here fs.default fs. What is that we have? What is the value for that one? That is the name of the property. That is the name of the property. What is the value to that? That is your URL. That is your URL. HDFS IP address of your master, that is nothing but your name node, the port number. Say for example, you have at the root level you have TMP, and under that we have sandbox, and under that you have a file called Mary. This is called the relative path. When you are within the cluster, as a user, you are within the cluster, then you have /tmp/sandbox/Mary, that you want the data set. But if the same needs to be accessible to you, then HDFS master.techiebs.com :/TMP/sandbox/Mary. I think now you got the understanding what I mean by the URL here. URL is URL anywhere. Let it be your HDFS or in the context of your web or in the context of networking. URL has got the same structure: protocol, IP address, port number, resource name. We got the protocol here. This is what the protocol. We got the protocol. What the protocol? This is IP address or domain, and this is a port number, and whatever you are seeing here, this entire thing is what we call it to be the resource name. So we are very clear. This is a protocol and this is the IP address or domain, whatever, and this is the port number, and this is the resource name. Whatever we have specified here is a resource name. Why these are important for us? Because when you are copying the data from one cluster to the other cluster, we need to have this one, because all these days you are working within the cluster, so you are not much worried about these things. But now, when you need to move the data from one cluster to the other cluster, then we need to have the URL, without which you will not be able to do that. That is the reason why we are trying to look into this. Make sense? It makes sense, friends?
Yeah.
Yeah. So how we come to know that one is by looking into your core-site.xml or hdfs-site.xml. You'll come to know fs.defaultfs. This you can see even from your Cloudera manager also. You can see that from the Cloudera manager even. The compression codecs and all those things, what are possible on your cluster, all those things you'll be able to see from the respective configuration files. So here if you see, the Cloudera manager provides an integrated, easy to use management solution for enabling data protection on Hadoop platform. An easy to use management solution for enabling data protection on the Hadoop platform. Cloudera Manager enables you to replicate data across data centers for disaster recovery scenarios. Cloudera Manager enables you to replicate data across data centers for disaster recovery scenarios. What do you understand from this statement? See, what is disaster recovery basically?
If the cluster goes down or something happens to the data center, you'll have another standby data center or cluster somewhere else.
So disaster recovery is something very much similar to your data replication only. So within the cluster, the disaster can be recovered with the help of replicated blocks. Something goes wrong with a block, we have another two blocks of the same on different nodes in the same cluster, so that your processing will not be affected. For any reason, if the entire cluster went off, whatever the reason, data center maybe physical damage or whatever it is, your data needs to be available at some other. That kind of setup is what we call it to be. The ability to recover the data even in the physical disaster is what we call to be disaster recovery. Cloudera Manager enables you to replicate data. That is how we can implement disaster recovery. Cloudera Manager enables you to replicate data across data centers for disaster recovery scenarios. We'll see this one. Replications can include the data stored in HDFS, data stored in Hive tables, Hive metastore data, and Impala metadata associated with Impala tables registered in the Hive metastore. When critical data is stored on HDFS, Cloudera Manager helps you to ensure the data is available all the times, even in case of complete shutdown of data center. So, in order to make your replication and all possible, make sure the following ports are open and accessible on source host to allow communication between source and destination Cloudera Manager servers and the HDFS Hive MapReduce and Yarn hosts. This is the important point that needs to be kept in the mind, friends. Either you off the firewall, that is one way, that is not advisable, which we don't do it. And we need to make sure the system admin is going to ensure that the following ports are available. The following ports are available, right? Now, You see that here. To make this possible, you actually need the source and the destination cluster must have a Cloudera enterprise license. Then only it is possible to have this replication. I mean, if you are doing through this, both the source and destination clusters must have a Cloudera enterprise license. So that is one thing that needs to be kept in the mind. I think you are looking at this one. I mean, clearly. You are looking at this one clearly. What is that? Both the source and destination clusters must have a Cloudera enterprise license, right? And you also need to look at these points closely, friends. On the destination Cloudera manager instance, we need to make sure, because you are going to copy this data. That is where I mentioned recursively, and you know very well that once you initiate this replication, it goes recursively. That is where usually at the time of setup, what we do is have a look at this. HDFS service, go to the file browser. As part of that, you take any directory.
Srini, are you showing something, because I can see only the Word document.
Now I move to this Cloudera Manager console. Arun, you're not able to see that?
Okay, no, we don't see that.
Oh, really?
Yeah, now I see it. Now I see it.
Okay, okay. I think there is a
It
lag
is
time.
little slow. Cloudera manager.
Okay, fine. You see here, what is that? You can manage the quota. You can manage the quota to the directories that you maintain on your cluster, so that they will not go beyond. They will not go beyond. And this is going to be highly helpful during your replication or moving or copying the data from one cluster to the other cluster. Of course, rarest of the rare cases where that number is going to go beyond, but still, as a precautionary, we can always do that. This provision has been made. What is that? Select the file count limit for this directory. You have do not limit file count. We have limit file count to whatever you specify. And you also can specify, select the disk space limit for this directory. You can specify whatever the GB you want. I think you understand. And even if you want, you can use TB. Whatever the TB you specify. Right? That is how you can manage the quota to any directory. This is not from your U browser. This is from your Cloudera manager. You can manage the quota of a directory in your Hadoop distributed file system. I think you are.
So Srini, Can I define the volume where it should go to?
But that cannot be,
Like I want the
I got your point, Arun. See, that is where I say every time, we need to forget that we have many hosts in the background. When you are working with any distributed file system, not only this one, you're working with any distributed file system, we need to forget there are many hosts in the background. The reason I'm saying, like how you look at, I say, yes, this is a very good example for you to understand. Forget about your cluster. This is a machine. This is your CentOS box, which has got multiple hard drives within it. That is the reason why I'm showing you here. 4 hard drives you have. Now you as a user, you logged into this machine to the terminal. You ever come to know that there are 4 hard disks here? Now I tell you the same. I have been connected to this machine. ls-al, I said /. I only will come to know what is the directory structure at the root level. There exists only one root, and what the directory structure you have at the root level, that only I come to know. Whether this file system has spread across 2 hard drives in the background or 3 hard drives in the background or 4 hard drives in the background, you never come to know that. You agree with me?
yes.
In the other way, I say, now I have here this PC, C drive and D drive. We only have got drive here. But you ever come to know how many hard drives are there in the background? Of course, if you go to the device manager level and all, you will be able to come to know. That's a different story. But as a user, you ever come to know that how many hard drives you have here? You only will have drive. That is the logical division you made on the same hard drive. On the same hard drive. I have allocated 210 GB for C drive and around about 255, I think it's around about 300. That is 210, 210 or 220. And here somewhere around 260 somewhere. Altogether 500 GB hard drive this is. That is how I have divided here. That is how I have divided. Okay. But we come to know this one only when you go to the device manager. Now same, when you are talking in terms of the cluster, the entire cluster has got only one root. Many hosts, but there exists single root. And under this root only, you have the entire file system. Now, specifically, under this, you have other subdirectories. Under this, again, you have subdirectories. Under this, you have subdirectories. Where physically this exists, where physically this exists, where physically this exists, we are least bothered. I hope you are getting my point. And that should not be definitely in the control of, the user. If that is kept in the control of the user, disasters will happen. Because unbalance and all these things arises because of that only. Arun, if I'm not wrong, I think that is what your question is.
Yeah, I mean, the reason I asked is, suppose I have some critical data that I want mirrored. So what you're saying is you cannot go by volume, I should go by folder. I should put the critical data in a particular
That is the
folder
reason
and then
why
mirror
we
that.
have the concept of snapshots, Arun. That is the reason why we have the concept of snapshots, and these snapshots can be scheduled by you or can be taken by you manually. Both the ways we have. That is the reason why we have the concept of snapshots. We can take this snapshot of this directory whenever you want. By taking a snapshot, what happens? It is something like your database the save points and all. Database save points and all. Any point of time you want, you can restore your previous snapshot. You can always go back to your earlier snapshot. So I think that is what your need is, some critical data, and you want to protect it against corruption or whatever it is, then you always can use this snapshot concept where your problem is been addressed.
Okay.
You got my point?
Yeah, got it.
That one snapshot. I think yes.
So this application you're talking about is nothing but mirroring, right? That's what you're talking about.
Replication is something like mirroring only. Yes, but snapshot is different from mirroring. Snapshot is different from mirroring. Snapshot always works with those deltas. Snapshots always work with those deltas. So you have already taken a snapshot and you made some changes to that file system and all, and you want to take this snapshot again. So what difference that has happened, only that is been taken as a snapshot, because it is going to maintain. That is where I'm saying here, a snapshot is just nothing but HDFS snapshots are read-only point-in-time copies, read-only point-in-time copies of the file systems. Snapshots can be taken on a subtree of the file system or the entire file system. Some common use case of snapshots are data backup, protection against user errors, and disaster recovery. That's what the theme of the snapshots. Okay, so we talk about that one, how we take these snapshots and all, we talk in detail. But I think you understand here, whenever we are doing this replication, I mean the copying of the data from, I think yes, maximum number of files for replication schedule that runs more frequently than once in 8 hours. There is a limitation there. 1 second, friends, 1 second. Yeah. So as we have this kind of limitation, that is the reason why we talk about. That is what we talk about here. The maximum number of files for replication schedule that runs more frequently than once in 8 hours is 10 million. because we are going to schedule this replication. We are not going to do it manually. How we do that one, I'm going to show you. The maximum number of files for a single replication job is 100 million. Maximum number of files for a single replication job is 100 million. Now, because of these limitations, and you also need to have one more. The high latency among clusters can cause replication jobs to, I don't know what you understand from this one. High latency among clusters can cause replication jobs. What do you mean by this? Replication jobs. Is it a job? Replication is also a kind of job.
It is basically a process, right? So that is run as a job. I mean, you can schedule it so that the process runs and copies the data.
Yeah, it is also a MapReduce job in the background. Your data replication or data copying is also a MapReduce job in the background, where you can fix the number of mappers that needs to work for you in the background to do this data copying without impacting the cluster accessibility for your current activity. Usually, you do this data replication in the off-peak time. You'll not be doing that during peak time, but still, that is where we need to understand. So each statement will have a detailed meaning in the background, provided you look at that in the expected dimension. High latency among clusters can cause replication jobs. What do you mean by this latency? What do you mean by this latency?
There's a speed. It's opposite of the speed. Means there's a delay.
Yeah.
Slowness.
So you can see this is what the latency, I say. 50.2 milliseconds. That is what the latency. I think you noticed here, there is almost an plus or minus the same latency. I mean the time taken to respond. So here you see, the high latency among clusters can cause replication jobs to run more slowly, but does not cause them to fail. But does not cause them to fail. But does not cause them to fail. For best performance, latency between the source cluster name node and the destination cluster name node should be less than 80 milliseconds. I hope you are getting the point here, friends. So of course, this is all the responsibility of the system admin to ensure that the latency between the source and the destination cluster's name node is less than 80 milliseconds. So like how we are having the latency here. I think you noticed here the latency. So same, when I ping from my source cluster to the destination cluster, it should not be more than 80 milliseconds. Of course, all these are the factors that influence your that is going to influence your replication aspect. That is going to influence your replication factor or the replication aspect in terms of the cluster. Okay. But you see, you can test the latency. That is what I have shown you now. Cloudera has successfully tested replications with latency of up to 360 milliseconds. As latency increases, replication performance degrades. I think you got the understanding. And these are some of the consideration points that needs to be kept in the mind during your replication. This makes sense, friends, for you to understand. Now,
Yes.
you go to this one, you see here, this directory called sandbox is already been enabled with the snapshots. is already been enabled with the snapshots. Now I go here, I can see all the snapshots that are available for this particular. I can disable the snapshots or I can take a snapshot. When I say take snapshot, I give the name, that is something called May. You can see that here, 09 or 011 or 11, 052017 snapshot assume. Say okay. You see what it is doing, waiting for process HDFS, and you see here what is happening. You can look at that one closely here. What is that? Current working directory. You can see, you can study this one detailed and you can get it. Say, I have one more snapshot that is now. I think you noticed here. Whatever the name it is.
So the first, so Srini, the first snapshot will be the entire file, right?
Exactly.
The entire directory.
Exactly.
Subsequent snapshots will be the data.
Exactly. What are the changes being made? That is what the beauty part of these snapshots. It will not take the entire each time. It will take, if it takes the entire each time, then there is no meaning in that, right? Then there is no meaning in that. That is what and moreover, this is a read-only thing. We cannot edit that one. The only option we have is delete. We cannot edit the snapshot. We cannot edit the snapshot here. I think you can see that here. In order to take the snapshot, you need to first make the directory enabled for snapshots. Then only you will be able to take. Restore directory from snapshot. Then this makes you, I think you see here, all the snapshots are available to you. You can restore to that snapshot. The directory what you have chosen, you can restore to that one. Now you see closely here, I go to a different directory, maybe user, you can see that here. You see that here? But if I click on that, enable snapshots, HDFS enable snapshot on, whatever, okay. And now you go to this one, you'll be able to see that. Are you able to see that one here, friends? Earlier that was not possible. In order to take the snapshot, you need to first enable the snapshots on the required directories. Then only you will be able to take the snapshots. But you can always disable the snapshots on the directories. You can always disable the directory, disable the snapshots on the directory. So taking the snapshot is possible only when you enable the snapshots on that particular path. Instead of me calling it as a directory, I say it is a path. Okay. So, and you also has got one more thing what has been mentioned by me here. That is, you can limit the quota on any particular directory. That is always in your control. That is always in your control. You can see that here. The usage, the directory usage. the directory usage for this one. The detailed, whatever you are selecting, you can select that one and you can manage. You can include this one as part of disk usage reports. I think you remember disk usage reports you get at your HDFS level and even at your Cloudera manager level, at the root level, home level, you'll be seeing the disk usage and all. You don't want certain directories or certain paths on your HDFS to be included as part of your reports. You can always do that. Include selected directories in disk usage reports or exclude selected directories from disk usage reports. You can manage the quota for the selected. That is what we are doing earlier. I think you noticed, right? So this is all at your storage level. This is all at your storage level. That is what we are doing at the HDFS level. If you go and work with your file browser, of course, the file browser, what you are seeing here as part of the Cloudera manager is different from your file browser which you are seeing. HDFS browser you have as part of you also, and that is different. And that is different. You can say here rename, move, copy, change permissions, and you can delete the directories or the files present in the given path. So that all is something like the file management. What you're doing using your Hadoop FS. As a developer, what all you can do with Hadoop FS, that all you can do it using your Hue browser. That is what you see here. All these commands are possible even from your Hue browser. Hope you are getting the point. But from the Cloudera manager, you go to the file browser, you will have more control in terms of your storage. You can enable the snapshots on the path you require. As part of the reports, you want these directories to be included or excluded, and you have the provision to take the snapshots and all if the snapshots are enabled on that particular path. Right? Hope this is clear. Now, based on this only, you can define your snapshot policies. Create a snapshot policy. You see here, you only can see what all the paths that are enabled with snapshots here. You cannot see other things. Now, I give some name, sandbox snapshot policy. Assume this is a sandbox. So what is going to happen? Schedule this every 1 hour, daily. I think daily when you select, you get take snapshots every day at whatever the time you specify. I hope you are getting my point, friends. And take snapshots every hour at whatever the minutes you specify. Weekly, you specify. Take the snapshot on so and so hours and minutes on particular day you want. I hope you are getting the point here, friends. Monthly, the day of whatever month, whatever the day of the month. The same, even yearly you have. So alerts needs to be sent to the admin. The admin email has been configured. Alerts are being sent on the failure, on start, on success, on abort. So whatever you choose, for all those events, the alerts are going to be sent to the admin. I think you are getting the point here. This is what we call it to be the snapshot policy. You want, whenever you want, you can go, that is on demand. You can go and take the snapshot of a particular path on which you have already enabled the snapshot. You also can automate this one by selecting the path. You can enable you can create a snapshot policy and make that to work as expected. I have already mentioned here, snapshot is just nothing but the read-only details of the file system. The read-only details of the file system. It's going to capture the what is the status of the particular file system and the path, whatever you mentioned, and what is its size. Only the meta information is going to be captured there, not the entire data. Only the meta information. Only the meta information. Snapshot doesn't carry the entire data. If entire data you're taking a snapshot, then it is something like replication only. So snapshot will only have the metadata. It will not have the entire data present inside. So depending on your need, you can always make these snapshot policies created on different paths. I think Arun, you got the right answer to the question what you have raised. If some data you feel is critical to you, how you can protect that one? I think you have the quite interesting answer, because you will come to know how your data is getting pumped. Maybe from external sources you are getting data getting pumped into the respective path, and if you feel the data is important, you know very well how data is getting pumped there. Based on that, you can create a snapshot policy, and thereby you can protect your data against whatever. You understand this one, Arun?
Yeah, got it, Srini.
And the replication schedules now. See, we need to understand clearly the difference between the snapshot and the replication. Snapshot is different from your replication. Snapshot is different from your replication. You can see now here, see, look at the replication. Source path, destination path, and the schedule, whatever the username with which you want to run this replication, you specify all those details. Source is this one. Okay, source is your HDFS dev. That is what the source is. What is the destination path here? What is the destination path? Maybe in US you have one Hadoop cluster, and in Japan or somewhere you have one more Hadoop cluster. We try to establish the replication between these two. We try to establish the replication between these two, so that in the event of disaster, something goes wrong with the where this Hadoop cluster is being set up, either within the organization data center or maybe on a host data center, whatever. Usually Hadoop data as of now not been hosted except these big companies where they have some tight policies in place and all. But at least the small players, I don't think you need their cluster to be set up on data center. It can be within the organization on premises, maybe 10 node, 20 node Hadoop cluster. I don't think is difficult for the organization to maintain. So this Hadoop cluster may be within the organization or maybe hosted on a data center, and one more Hadoop cluster in some other geographical region, you can establish the replication between these two clusters. How we do that one? That is what we are seeing here. Source path and the destination path. Now, I think you understand why I discussed this point sometime before. Hope you got the point here. So if I specify route, usually we don't do that because under route we have many things that are specific to the user. You don't want all that, user specific data and all. You don't want to protect it, or you don't want to be a part of the. That is all depending on the organization strategy. Okay, you want every bit of your cluster to be replicated. That is different. Route you specify, then your entire cluster is being replicated. Otherwise, as part of this cluster, you are going to choose some path, maybe data, and under that you have subdirectories and all, and each subdirectory used for a specific purpose. This is for purpose A, for purpose B, C, D, like this. Under this, all the relevant data to purpose A, and under this you may have, again, this is organization specific. This is organization specific. How they maintain this this structure depends on their need. Now, based on that, we are going to specify here what is that needs to be replicated, source path and the destination path, and when it needs to be, when the replication needs to be scheduled, immediate, once, recurring and all. I'll show you immediate, once, recurring and all, and what is the username with which this needs to run. Okay, now I think you see here what is this maximum map slots, maximum bandwidth, replication strategy. What do you understand from this one? So I think I've already shown you there that this is replication is also a job running on the cluster, where you only has got the map. There is no reduce activity. That is why you don't see anything reduce here. Maximum map slots that are being allocated. Why we restrict this one? So that your cluster is not going to be impacted. Your cluster, if you give more here, then your cluster will undergo pressure in terms of running the map reduce jobs, directly or indirectly. That is the reason why we are going to lock the maximum map slots that can be used for this purpose. You specify that there. You getting the point here, friends? And the maximum bandwidth that can be consumed. If the entire bandwidth is being consumed by this one only, then your other jobs running on the cluster will suffer. Not to happen that one, this we are using. And you see, the MapReduce service, the log path, the error handling, and the delete policy, and the alerts. By giving all these things, you'll be able to create a replication schedule. Now I think you see here, you can create your replication schedules and make them available on your cluster, and you can either disable or enable them even after the creation, or you can delete them. You can delete those replication schedules that you have created. Now you see this one, you see this closely. See here, the source HDFS cluster, the destination HDFS cluster, next run, and what is the MapReduce job that got executed for that one. What is a command that is getting executed in the background? Replication job on you see that here. Uh, where you see that one here. What is that mapper that is functioning in the background? What is that mapper that is functioning in the background? So this mapper, I mean, whatever the number of mappers that are required, I don't know whether, I mean, maybe too in detail, not good to discuss as part of this, but to give you the understanding, your MapReduce API has got built-in mappers, identity mapper, there are built-in mapper classes that are already been developed and kept ready. So whenever, if the same key value pair needs to be emitted out, you don't want to do anything because you want to do the activity in the reducer, not in the mapper. Then you require an identity mapper which is going to receive the key value pairs and as is passed to the reducer. Then I'll be having something called identity mapper. You may ask me one thing, Srinivas, that is the case, why a mapper phase needs to be there? So according to the life cycle, you can go to the reducer only when the map phase has been finished. Then you have your partitioner, shuffle sort, then only you can go to the reduce phase. You cannot directly go to the reduce phase. Because of that only, you have some built-in mappers developed and kept ready. One such mapper is your copy mapper, whose job is to copy the data from one cluster, I mean, one path to the other path. That is what the responsibility of this copy mapper, with which you are able to copy the data from one path to the other path. And both are being given. That is where we have given the source path and the destination path. Now, whatever the replication schedules that are being created by you, you can make those replication schedules. Yes, you can make those replication schedules to get executed. I think you see here, you can run now. You can run this now. Whatever the schedules that you have created, you can make those to get executed based on whatever you specified, or I think you can see this here. You go to the edit configuration once, only once. If it is recurring, you are going to see here interval 1 days or how many days. How many days this start time is what you are specifying, and the interval of every 2 days this needs to be executed, or this is immediate. So based on your need, you can create your replication schedule and make that to get executed. And as part of that one, we are already specifying how many map slots and all that needs to be used. All that stuff you specify. Accordingly, the replication will happen automatically. So you plan something like this now. You have one of the cluster present here and the other cluster in some other geographical region. depending on the sensitivity of the data that you are getting into the cluster, you can schedule your replication and make that to happen automatically on the cluster. So you can create and schedule. You can create and schedule I think you got the point. Create and schedule the replication. Based on that, the data is going to be replicated on the other cluster. And this itself is what we call it to be disaster recovery. You're getting the point here? Within the cluster, there is no concept of disaster recovery. Within the cluster, within the cluster, your block replication itself is going to be your fault tolerance. Something goes wrong with the block, then we have other blocks available, or if the node is down, then the blocks that are supposed to be on that node are being replicated on the other nodes uniformly. If the name node is not going to receive the heartbeat from that node within the stipulated time, then the name node understands something went wrong with that node. What blocks are supposed to be on that node, all those being replicated on the other node so that the replication factor is being consistently maintained. I hope you are getting the point here, friends. Now what we are doing here, we are replicating the data of one cluster at a different geographical location on the other cluster so that even in the event of this cluster failure, complete failure, you have your data being preserved there. And for that sake, you need to design and you need to identify the volume, the rate of the data that comes into your cluster. And based on that, the replication needs to be scheduled. And that all depends upon how you are getting the data into your source cluster. Based on that, you need to schedule the replication onto the, but for sure, something extremely goes wrong. I mean, that is rarest of the rare, but yes, that possibility is all, that threat is always there. That small, the delta, what is being left over, which is not being replicated on the disaster recovery site, okay, that is being lost. There is no alternative for that. If you don't want to lose that one, then the replication scheduling needs to be in such a way, the moment you have some data into a particular path, be crossing beyond some volume limit, you need to ensure that the data has been replicated on the disaster recovery site. So that even in that case, within the latency time, what data is been missing, that is been lost. So that we don't have any solution for that. You understand the point here? So with the data, with the replication scheduling, what is been done, with the replication scheduling, what is been done here, you will be able to copy the data of one cluster into the other based on whatever the details you have published here. This is one thing. Usually within the same environment, I mean, you have again the landscape, something like this. Within the organization, if you see closely, you have your development cluster, and then you have your testing cluster. You have your testing cluster, and then you have your production cluster. Now from this production cluster to the this is a recovery, disaster recovery cluster. We create the replication schedule here, and now data also needs to be moved from here to here or here to here. The data needs to be moved. So that is all been taken care using your simple DistCP and all. You can do that one within the environment. So for that sake, we need not do any of this scheduling and all, because we only move some required data from production to development so that we can use those data sets for the sake of your testing purpose and all. So for that sake, we may not be doing all these replications and all. I mean, scheduling and all, we will not be doing. We only, maybe max required, you can create once and do it only once. That is what I'm trying to show you here. Are you able to see the screen, friends? I think it is.
Yes, Srini.
I think it is responding a bit slow. Yeah. Yeah, it is responding a bit slow. I don't know. Still coming. Yeah. Oh, why this is coming so episodious? Let me log out and log in again. Don't know why. It was happening till now is good. You're not taking even much time, much resources. Let us work here.
Srini,
Yeah,
I'm getting a message saying that the organizer is experiencing technical difficulties and the meeting will end in 5 minutes.
but no such thing from mine.
Okay.
Even I could see that like the organizer is experiencing technical difficulties.
Oh, really?
Yeah.
Maybe is it because of the internet issue that it is been slowed down? I'm not, because let me also check that. That should not be the case. That's where I'm wondering, because nowhere we have that. It is also taking a lot of time. 1 second. Because even my VMware vSphere client is taking more time.